Good afternoon, everybody. My name is Raman. I'm from the University of Antwerp in Belgium, and the title of the work is the topic of the work is taking motion capture outside a lab. So off-site, meaning not lab site, but a portable motion capture system, specifically for tracking the joint angles of a human body. I come from a sports science background, so if I don't use some of these terms correctly, please correct me. Right, so motion capture goes back to more than a century, even more actually, back to when cameras were invented. Essentially, it's just recording and tracking of human movement uh, in the mainstream. And the medical and research communities extensively use them, as well as entertainment, sports, broadcast, and performance analysis industries. Traditionally, mocap or motion capture is optical, so it's based on cameras and a camera setup of a 360-degree camera setup where infrared uh, cameras are used to track individual markers that are fixed on a subject or an object, and then through triangulation the position is estimated. So that's the traditional way of motion capture, and it still tends to be the gold standard in accuracy, but it is expensive and it's restricted mainly to a lab, and it does suffer from other drawbacks like cameras cannot always see because the human body is so complex in articulations that some parts tend to get hidden no matter how well the cameras are set up to see. So alternatives came up in the last few decades as a cheap substitute for optical mocap, and they came in broad. They were quite various. They were camera based or sound based or strain gauge or other electromechanical system based solutions. But the superstar, so to speak, has been IMUs because for various reasons. And IMU is a combination of accelerometers or gyroscopes, and they're called with various acronyms, but I tend to use IMU in the rest of the presentation. Um, it's targeted to a wide audience, so they're also designed to be user friendly. You don't need a lot of skill to be able to do motion capture with them. And it has been validated several times for movement tracking, but what we are interested to know is it super accurate? So when you need high accuracy data, can you rely on these off the shelf solutions that come as cheap as a couple of $100? Because our research group focuses on modeling the human body to a very high resolution, and we were interested in acquiring one ourselves, but we couldn't test the several dozens of products out there. So what we do is we wanted to this is actually the first step of a systematic review. So any feedback that you might have would go into building the rest of this work into a full systematic review. Yeah, so the aim was simple. We wanted to review studies that tested the accuracy of these commercially available mocap systems, specifically to measure the joint angles of humans. And our goal was to identify the most accurate, but this can also help other practitioners to identify the most suitable system for their application. Lag. Yeah. So the inclusion criteria is that authors should have quantitatively measured joint angles, not just gesture recognition, for instance. They should have done it against a benchmark system, and the product that they were testing should be, in theory, uh, be able to function or perform outside, even if the tests were performed indoors. They should be commercially available at the time of writing this paper. It should have been with recruiting human subjects and not robotic arms, for example. And of course, it should be published work. We ourselves test some of these in our lab. Uh, so you see the IMUs are either stuck or they're fixed with Velcro sleeves. And there's a little video, I hope it works, just to give you an idea of, you've probably seen this. So on the right, you see someone wearing this set of 15 or 17 sensors. And on the left, you see their human model, in fact, real time. I'm just going to skip ahead. Yeah, so this figure is slightly wrong. We've had more than 500 publications in the long list, and after various, exclusion criteria, we ended up with 21 publications that we were interested in. The range of publication was over 9 years, from 2009 to 2017. And that's understandable. The Isaac's presentation said that 2004 was when, well, his timeline started in 2004, and a few years later, commercially, they started being produced. And about 45 of them, more than twice the number of publications in our long list, was excluded. And the most common reason being that they were not commercial. They were one-off, lab-built, sort of homemade, quite fantastic products, but still they were just not available to purchase. Anyway, in all, there were 228 participants part of this systematic review. As you can imagine, it was for human, joints. So majority tend to be in medical and healthcare journals. Of the 21, almost 18 of them used IMU-based solutions. There were 13 unique manufacturers, and most of them used optical mocap as their benchmark. And the three most common metrics published were root mean square error, some form of correlation coefficient to see if the times over time, if the joints were accurately tracked, and an absolute difference. So just a difference and that averaged. We divided the studies into any joint at the hip or below, we called it lower body, and then the rest was called upper body. And this is just an overview of what the results were. But most striking is indeed that the spread of errors is quite wide. You'll see that cumulatively it ranges from 0.7 degrees, which is actually quite great value for money, and up to 12 degrees, which was almost expected when you think of you get what you pay for, because you spend thousands of dollars in buying a Vicon optical system and you're guaranteed sort of that accuracy. But if you buy something just off the internet for a couple of $100, that's expected. Anyway, that's just from a commercial consumer point of view. But you don't have to, these results look better on paper, but just to show you that the spread is quite large. And this is also depending on which joint was studied and what activity was under question at the time. And this is just a root mean square error. Right, so there was no surprise that IMU-based products were popular. And if one would assume that the quality of these individual sensors would improve over this time period, but which means the results, the accuracy should improve. But we saw no negative or positive trend over this 9-year period. So does that mean that it's the algorithms that are the that have the biggest influence, the sensor fusion algorithms on accuracy? We also divided the activities. They ranged from simple gait or walking tests to complex factory worker day-to-day activities, and there was no trend there as well. So just because the activity was fast doesn't mean that it was more error-prone. Well, majority used optical motion capture, but something to think about is that IMU and optical motion capture, essentially they measure very different things, and how they estimate is also indirect in their own way, although they measure the same thing, human movement. And optical motion capture has its own error over the years based on the setup, how many cameras were involved, how the markers were uh, positioned, even the modeling of the joint. Some researchers, simple elbow joint is modeled differently because the elbow itself has various landmarks where you can pivot the joint, and that's a subjective. There should be a more standardized methodology, is what we observe. And the error also depends on the range of motion of the joint. The human body has, so many complicated um, joints that, for instance, there are some joints who only range up to 4 degrees, but the knee flexion, for example, goes from, in a normal case, it goes up to 130 degrees. So we noticed that a high error was noticed where there was a high range of motion. So perhaps they should have also declared an error that was relative to the range of motion. Calibration is left to the end user, which means the instructions are very simple, which also means that there's maybe some scope for ambiguity. So you are just expected to strap on these sensors and do simple pose. But many authors have shown that calibration can affect that session's error and that session's joint measurement. We also noticed that some of these excluded papers, which were not commercial products, but they were just built by one lab for, just for validation, they performed better sometimes. So does that mean that it's harder to mass produce and replicate? We don't know. Sensors do slip. The IMU is not all that easy to use. There's also relative motion between, when you don't tightly strap on the sensors. If you're cycling at 100 RPM, there might be some relative motion because there's also this sleeve that goes on, and there's the skin which itself is flexible. There's a lot of soft tissue involved. Whereas in optical motion capture, the markers are fixed on the bones to keep as little movement as possible. Also, majority or no, half of them focused on just one manufacturer. So one of our recommendations is that there should be more products should be studied by researchers. And there were some authors who predict that the future of pose estimation might not be in this field at all. It could probably be in optical flow and camera systems. So based on machine learning, for example, there were some who could estimate joint angles just from a set of images and teaching an algorithm to predict the right pose and joint angles. This is just a comparison of why IMUs are cheap and why they're popular and why optical motion capture is more accurate, but it's not so important. Right, so to conclude, inertial systems tend to be very popular. There was a wide range of errors and several factors being the joints, the algorithms in question, and the method of calibration. And we would conclude that no one system or methodology was consistent under all circumstances. However, under ideal conditions, we saw some fantastic results, like less than 1 degree, which is even better than some of these Vicon and optical systems. So this research is funded by the University of Antwerp and Foxtail, which is my employer, and the Flemish Agency for Innovation and Entrepreneurship. And thank you very much for your attention. I would like to get some feedback so we can continue to make this systematic review complete. And if you have any questions, I'll try to answer them.
Thank you.